Students, in this class we will study complex numbers. Now, before we could understand what a complex number is, you will have to know the number system that we have got. Okay. Now, the first is the natural numbers. Okay. Natural numbers. Now, they are represented by the letter N, and they start from 1, 2, 3, and they go up to infinity. Now, these numbers are also called as God-given numbers, right? Now, after you have what is called as whole numbers, right? Now, whole numbers are represented by the letter W, and they start from 0, 1, 2, 3, and they go up to infinity. Now, after whole numbers, you have what is called as integers. Now, integers are represented by Z, and they are from negative infinity, negative 3, negative 2, negative 1, 0, 1, 2, 3, and they go up to infinity. Now, in integers, you have what is called as negative integers and positive integers. So, positive integers will be consisting of plus 1, it starts with plus 1, plus 2, plus 3, and they go on up to infinity. Okay, so negative integers will be from the negative 1, negative 2, negative 3, and they go up to negative infinity. So, to write the set of negative integers, they would be negative 1, negative 2, negative 3, and they go up to negative infinity. Of course, as I mentioned to you, positive integers are plus 1, plus 2, plus 3, and they go up to infinity. Now, if you were to see the set of integers, I've got a presence of 0 here, but I have not included 0 in positive integers. Neither I have included 0 in negative integers. So, that is the way it is. Okay. So, if you were asked to write the positive integers, then you should write this. This is the set. Now, if you were to ask to write negative integers, then you have to write this. Now, there is something called as non-negative integers. Okay. There is something called as non-negative integers. Now, if they were to ask that terminology, or they were to use this term, non-negative integers, then you can include 0. You follow me? But if they specify it as positive integers, you cannot include 0. Have it in mind. Okay, so having given you the definition of natural numbers, the whole numbers, the integers, now it's time that we have to know what you mean by rational numbers. Okay, rational numbers. So what are those? Now, a number is said to be a rational number. I'm writing the definition here. A number is said to be a rational number if it is of the form P divided by Q and Q not equal to 0. Have this definition in mind. So, having said that, examples of rational number would be 1 over 5, 7 over 9, 21 over 1000. These are all examples. 5, you can also mention 7, you can mention 91, and so on. So, these are all some of the examples for rational numbers. So, having given the definition of rational numbers, let us study what is called as irrational numbers. So, one of the noteworthy feature of a rational number is the representation in fraction form. I have that in mind. And we use the letter Q to represent the set of rational numbers. Okay. Now, having given you the definition of rational number, we have to know what is called as irrational number. Okay. Now, define irrational number. What is it? Now, a number, the definition I'm giving you, a number that cannot be represented in the form p divided by q and q not equal to 0 is defined, or you can use said or called, is defined to be an irrational number. Okay, now the set is represented by q dash. You can either call it as q dash or q prime. Okay, now examples, some of the examples of irrational number are pi, e, pi raised to the power e, e raised to the power pi, pi raised to the power log e, log root 2, okay, root 3, root pi raised to the power root 2, and so on. Okay, now the most popular example for irrational number is pi. Now, can you tell me the value of pi? Now, if you were to write the value of pi, it would be something like this: 3.141592658979323846264333. It goes on. Okay, it will go on. Now, for the sake of convenience, we take pi to be as 3.14, which is again taken to be as 22 divided by 7. Now remember, 22 over 7 is not equal to pi. Okay, it's not equal to pi, but it's approximately equal to pi. Or it is, you can use the terms here, it's approximately equal to 3.141. Okay, so pi, you cannot even say pi is equal to 3.14 because the digits are ever going. You follow me? So that is why this is the most famous irrational number. Now, having told you all about irrational number, and it is imperative that you have to know who exactly discovered irrational number. The name of the person is Hippasus. Now, who was Hippasus? He was a student of Pythagoras. Okay, Pythagoras. So, to become a great student, you should study under great teachers. So, have that in mind. Now, actually, Hippasus, what was his objective? His objective was to represent root 2 in fraction form. Have that in mind. He wanted to write root 2 in p over q form, but he ended up showing that root 2 cannot be written in p over q form. Okay, so have that in mind. He went on to prove that root 2 is irrational. So that is altogether a different study. So as of now, I hope you are getting a clear picture of the list of information that I'm providing you with regard to the number system. Now let us move on to another definition of the number system. Now you have what is called as the next number system, which is real numbers. Okay, now real numbers, they consist of irrational numbers, okay, irrational numbers and rational numbers. Okay, now irrational numbers are represented as q prime, rational numbers are represented as q. Now irrational numbers, rational numbers, they make up the real number set, which is represented with r. Okay, so this is the representation that you have to know. Now this is a infinite number system, okay, because it includes all the numbers from negative infinity. You can think of any form that you can have for a number, okay, that would be present in the irrational number system. Anything, for example, you want to see 1 over root 2, 1 over root 2 will be an element of a real number system. You want to see root 3 will be element of the real number system. You want to see pi raised to the power root 2, it will again be an element of real number system. Or if you want to see e raised to the power pi times log root 2, this will again be an element of the real number system. So this is a very powerful system, and this is very much involved in securities, software securities, computers, so that this system plays a very key role in the modern technologies when it comes to security, pin codes, passwords, passcodes, and all these things. We use real number systems. Now, coming back to this term, or coming back to this topic, complex numbers, why did we exactly need to know all of these? For the simple fact, if I were to give you x squared negative 4 equal to 0, then you would be able to tell me x squared is equal to 4. Therefore, x is equal to root of 4. So, x is equal to plus 2 and minus 2. You would be able to arrive at the solution. But if I were to give you x squared positive 4 is equal to 0, then you would end up with a term something of this fashion. X squared is equal to negative 4. Therefore, x is equal to root of negative 4. Now, this is a square root which contains a negative quantity. So, immediately students will say, therefore, x is undefined. Okay. Why are they telling you this? To the very fact that they have not been exposed to the complex numbers. Now, why do we get this issue? Why do we get this issue? Now, take for example the graph, say x squared negative 1 is equal to 0. You would have x is equal to root of positive 1, root of 1, right? So, from here, clearly you can have x is equal to plus 1 as a solution, or x is equal to negative 1. So, what does exactly mean? X squared negative 1, I can rewrite this as x plus 1 multiplied with x negative 1 is equal to 0. So, I'm getting two values. So, what is the meaning of this? The meaning of this is, if I were to draw this graph, say when x is equal to 0, when x is equal to 0, the intersecting for this graph, x squared negative 1, y will be equal to negative 1, right? So, there is an intersection at the point negative 1. So, if I were to take this point as a negative 1, and the roots are negative 1 and positive 1. So, what exactly does it mean? If I were to draw the graph would look something of this form. Okay, so I have two intersection on the x-axis. Okay, two intersection on the x-axis. So, this means there are two roots. There are two roots for this function. X squared negative 1 or y is equal to x squared negative 1 has got two roots, two functions. That at 2 points, the graph is basically cutting the x-axis. So, that is the meaning of this. Now, roots are very important. Now, why roots are important? Because it allows us to solve the equation. Okay, and this has got application in all real sciences, all exact sciences. So, that's why roots are very important. Now, take the case, okay, this is case 2. Imagine this is case 1. Take the case where you have x squared positive 1 is equal to 0, or you are given y is equal to x squared positive 1. Now, in this case, you get x is equal to, in other words, x squared is equal to negative 1. So, therefore, x is equal to root of negative 1. So, you are getting something like this. Now, if you were to draw this graph, then this graph, when x is equal to 0, okay, the intersecting point will be 1 on y-axis. So, the graph is going to be something like this. So, if you were to see the graph has got no intersection on the x-axis. No intersection. Okay, there is no intersection on the x-axis. So, that means there are no roots. No real roots. Okay. But it doesn't mean that the graph cannot be drawn. But it has no real root. So, the meaning is there is always an imaginary root. In other words, you can always find a value that can solve this equation. But the only thing is that you will not be able to find them on the real axis. Okay, this is the real axis, real x-axis. You will not be able to find them on the real axis. Okay, so that is the understanding that you have to know. So where would you find them? You would be finding them not in the real plane. So we have got two planes. Okay, this is the real plane, x and y, and there is something called as the complex plane. I'm writing it down here, complex plane. Okay, so you will not be able to find the solution for these equations in the real axis, in the real plane, but in the complex plane you will be able to find it. To be able to find the solution for systems like this in the complex plane, you will have to define what exactly does this negative root mean. So that is why we have the birth of complex numbers. So what is a complex number? A number, you can write it down, a complex number is a number of the form a positive ib such that a is called the real part and b is called the imaginary part. Okay, now a is called the real part, so we write it as rp, and b we write it as im. We don't use ip. Okay, so have that in mind. So examples of complex number can be 8 positive 3i, 19 negative 4i, 15i, 71. They are all examples. Okay, have that in mind. Now comes to the very important point. Okay, defining the value of I. Okay, so as I mentioned to you in the previous question or previous issue, where we get x squared positive 1 is equal to 0 and x is equal to negative 1, root of negative 1. Okay, so this is the issue that we add. So this has to be dealt with. So we assign the value for I to be as root of negative 1. Have it in mind. This is a very important assignment, very important definition. I is root of negative 1 and I squared is equal to negative 1 and I cubed is negative I and I power 4 is positive 1 and I power 5 is positive I. They are all the standard representation that you have to know. So knowing this, suppose if someone were to ask you what is I raised to the power 100, then try to break 100 in forms or in multiples of 4. So I'm going to write this as I raised to the power 4 times 25. Okay, I can always do this because 4 times 25 would give me 100. Now I can further rewrite this as I raised to the power 25 raised to the power 4. Okay, why? Because a raised to the power mn is a raised to the power m raised to the power n. Okay, I can always use this formula. Now I raised to the power 25. I'm going to write I raised to the power 25 as I raised to the power 5 times 5. This is raised to the power 4. Okay, now this I raised to the power 5, I can write it as I raised to the power of 5 raised to the power 5. This is raised to the power 4. Okay, now what is I raised to the power 5? Now I raised to the power 5 is I. So this is I raised to the power 5. This is raised to the power 4. I raised to the power 5 is I. So place I to the power 4. Now what is I power 4? I power 4 is 1. So therefore I power 100 is 1. So like this, you can literally get the value for any values of I. Okay, just by merely understanding this table. This is a very important table that you have to know. So I can do another example. If they ask you to find what is I raised to the power, say 1024. Okay, this is a standard question. So what I'm going to do, I am going to disintegrate this, and I can disintegrate this using I power 4, because if I were to take 1024 and divide it by 4, 4 times 2 is 8, So 4 divides here 2 times 8, so 2 remainder. So 22, 4 5s are 20, carry 2 and 6. So 256 you got. So I can rewrite 1024 as 4 times 256. Okay, I can do that. So therefore, this is going to be rewritten as I raised to the power 256 times 4, which is I raised to the power 256 raised to the power 4. Now, what is 256? Now, 256 divided by 4. 6 4s are 24, carry 1, 4, so 64 times. So I can write 256 as 4 multiplied by 64, right? So this is going to be I raised to the power 4 times 64 raised to the power 4. This can further be rewritten as I raised to the power 64 raised to the power 4. This is raised to the power 4. Okay, I can make the following representation. Now, what is 64? 64 is 4 divides here 1 time, 2 time, 24. So 16 times 4. So this is going to be I raised to the power 16 times 4. This is raised to the power 4. This is in turn raised to the power 4. Okay, this is how you have the representation. Now I can further rewrite this as I raised to the power 16 raised to the power 4 raised to the power 4 raised to the power 4. Okay, now I raised to the power 16 is actually 4 multiplied with 4. Okay, so this is going to be I raised to the power 4 times 4 raised to the power 4 times 4 raised to the power 4. So I got this. Okay, now this can be further rewritten as I raised to the power 4 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 raised to the power 4. Okay, now this is 1. Okay, I raised to the power 4 is 1. Why? I know the value of I raised to the power 4. So that means this entire thing is going to be equal to 1. Okay, so this is how you have to disintegrate and then achieve the result. So let's move on to the next topic.